Welcome to another YouTube channel. If you are watching me for the first time, my name is L.S.T. I am a final year statistics student of the prestigious University of Ibadan. Okay, if you are watching my video for the first time, kindly hit the subscribe button, like this video. I beg do well to share this video with your guys. Okay, and comment if you have any questions. So today, I want to talk about the concept of moment and expectation. Okay, now. The concept of moment and expectation, I feel that the concept of moment and expectation, work hand in hand. Okay, in the sense that now in physics, you hear something like take moment clockwise, take moment anti-clockwise, right? In statistics, we take moment, but we take moment about the origin, and we take moment about what? About the mean. Now, I want to fuse in the concept of expectation into the concept of moment to show you that they work hand in hand. To my own belief, they work hand in hand. In the sense that, let's start with origin, moment about origin. Now, moment about origin, we denote this guy as mu r prime. Mu r prime, and this guy is called the root moment. The root moment about what? The root moment about origin. This guy is also called the raw moment. This guy is also called the raw moment. The raw moment. Mu r prime is called the root moment about the origin. We call it the raw moment. Therefore, if I say mu1 prime, we can call this guy what? The first moment about origin. First MAO. Mu2 prime will be what? Second MAO. Okay? Now, I now want to fuse in the concept of expectation into the concept of moment. This mu r prime that we said it is the root moment about the origin, or it is called the root moment. This guy is equal to expectation of x raised to power r. Let me write it this way for a reason that will be known soon. This guy is in terms of moment. This guy is in terms of expectation. Sorry. Expectation. Are we together? Okay? Sorry. Expectation. Mu r prime is in terms of moment. Expectation of x raised to power r is in terms of what? Expectation. Now this expectation x raised to power r. Oh, okay. It's an x raised to power r. It can be in two forms. It can be summation xr p of x, and it can be integral xr f of x dx. This is for discrete. This is for continuous. Expectation xr, the root moment about the origin, is summation xrp of x, so integral xrf of x. Okay, mind you, this p of x is what we call our PMF. Then f of x, small f of x, is what we call our PDF. Probability mass function, probability density function. Okay, so if I write mu1 prime, remember mu r prime is equal to expectation xr. Therefore, mu1 prime will be expectation x raised to power 1. Therefore, we can say expectation what? Expectation x. So, expectation x will be what? Or, let me write it this way. Expectation x raised to power 1 will be what? That's summation x1 p of x, or what? Integral x1 f of x dx. This is for continuous, this is for discrete. So mu2 prime will be expectation x square, and that will be what? That will be summation x square p of x, or integral x square f of what? F of x dx. This is for discrete, this is for continuous. This is for discrete, this is for continuous. That is that about the moment about origin, the MAO. Now, let's talk about the second one. Moment about the mean. Moment about the mean. Remember we said moment about the origin is denoted as mu r prime. Okay. So moment about the mean is denoted as mu r. And we call this guy what? The root moment about the mean. The root moment about the mean. The root moment about the mean. Okay. Now, if mu r is the root moment about the mean, therefore mu1 we can call it what? The first moment about mean, MAM. Mu2 we can call it what? Second moment about what? The mean. And mind you, just like what we have for here, mu r prime, expectation of xr, expectation xr, same thing applies here. Sorry? Mu r, we said expectation what? X minus mu raised to power r. Mu r prime is expectation of xr, expectation xr. Mu r alone will just be expectation x minus mu raised to power r. Okay? Now, if I write mu1, remember I told you that mu1 is what? First moment about mean. So mu1 will be expectation x minus mu all raised to power 1. Mu2 will be what? Expectation of x minus mu raised to power 2. Just like what we have for here, where we said mu r prime, just like what we have for here, where we said expectation xr is summation xr p of x, or integral xr f of x. So mu r, we can say, that's expectation x minus mu r will be summation x minus mu r p of x, or integral x minus mu r f of x dx. So mu 1, where we have expectation of x minus mu all raised to power 1, we can say that for discrete it is summation x minus mu p of x. For continuous it is integral x minus mu f of x dx. Okay, so that is that about the concept of moment and expectation. That is that about the concept of moment and expectation. So you just have to know that. Now let me teach you a little hack. Moment about the origin, root moment about the origin is R0. Root moment origin, R0. Root moment origin. Moment about the mean, root mean. Root moment about the mean, root moment about the mean, root mean. This is root moment about the origin. This is root moment about the mean. Okay, so now I've been talking about the concept where I said discrete, continuous, discrete, continuous. For discrete you sum, for continuous you integrate. Now, how do we know if it is discrete or continuous, or how do we know if we are to sum or if we are to integrate? We know through what we call the random variable. The random variable. Okay? So the concept of random variable, I'm going to explain it in another video. Okay? The concept of random variable, I will definitely explain on that in another video. because it is your random variable that you use to know if a function is a PDF, that is a probability density function, or a PMF, probability mass function. Okay, so thank you for watching. Like I said, kindly hit the subscribe button if you've not. Share this video with your friends that are struggling with moment and expectation. I beg. Okay, and do well to like my video. If you have questions, you don't understand anything, if this thing is still looking like jargons to you, okay, ask questions, drop it in the comment section. Me myself, I go answer you. Peace and love, guys. I love you so much.